Before we go on to the next page, I want you to check your work and see how you did with factoring these binomials. Now, what you noticed and what I noticed don't necessarily have to be the same thing. They can be different words, and you can notice different things than I do, and that's all right. Pause the video here so that you can look at what you wrote versus what I wrote. On this paper, it's asking us to go even further. Not only do they want us to tell if there's a GCF and to factor these expressions, but then they want us to use the zero product property and sketch the graph of a parabola. It sounds very much like what we were doing before, and we're just going to keep going with those concepts, but now do it with binomials. Is there a GCF between these two terms? Yes, there is. It is 3. If I factor 3 out of 3x squared, I'll get x squared. If I divide 3 out of 36x, I'll get 12x. And then when I go to factor this, if I do it with the area model, I've got x squared and 12x. So that would be x times x. I put this in the wrong spot, sorry y'all. 12x. And x times 12 would go here. So my factors, if I rewrite this equation in factored form, the GCF goes first, then the x, and then x plus 12. Now you could also think of this as 3 times x plus 0 times x plus 12. That would be okay. Now I'm going to use the zero product property. I take each one of these factors, this one and this one. X plus 0 is equal to 0. Well, x is 0. I could have done it with just the plain x here as well, even though it's not in parentheses. That is a factor. And then here, x plus 12 is equal to 0. Therefore, x is equal to negative 12. So one of my intercepts is at 0, 0. And one of my intercepts is at negative 12, 0. Is this parabola going to open up or down? Well, because the leading coefficient in front of the squared term is positive, it is going to open up. For this example, do I have a GCF between these two terms? Yes, I do, because the leading coefficient is negative. Negative 1 is my GCF, and then that's going to give me t squared. A negative divided from a positive is negative 36. If I think about this with an area model, this is t squared, this is minus 36. T times t makes t squared, and negative 6 and positive 6 will make negative 36, but these two items add to be 0, which is why there's no middle term. So negative 1 times t minus 6 times t plus 6. If I take each one of these factors and I set them equal to 0, and this one, adding 6 to both sides, t is equal to 6. 1, 2, 3, 4, 5, 6. That's one of my intercepts. Here, t is equal to negative 6. 1, 2, 3, 4, 5, 6. Does this parabola open up or down? Since this is negative, this parabola is going to open down. Two more examples. If you want to pause the video here and try these on your own, that would be a great idea. So if I have an area model here, I have p squared and minus 10p. So f of p in factored form is going to be p times p minus 10. Take this factor, set it equal to 0. 0, 0 is one of my intercepts. Take this factor, set it equal to 0. P is equal to 10. This parabola opens up with intercepts at 0, 0 and 10, 0. Here my GCF is 2, which gives us x squared minus 16. 2 times x minus 4 times x plus 4. Take each one of these factors, set them equal to 0. X is 4 and x is negative 4. 1, 2, 3, negative 4. 1, 2, 3, positive 4. This leading coefficient is positive. This parabola is going to open up. So an expression such as x squared minus 16, like this one here, this is known as the difference of two squares. Why do you think it has that name? Well, difference means subtraction. And squares means that these two numbers here, both of these are perfect squares. 25 is a perfect square because it's a number times itself. 49 is a perfect square because it's a number times itself. And anytime you see the difference of two squares, you're lucky because you know that the two factors have to be the same except for one's going to have a minus and one's going to have a plus. We're going to pause here and go to the next video to wrap up this lesson.